Hi, everyone. Welcome to our webinar, Zero Trust, How It Works. My name is Becca Lucero. I lead product marketing for Symantec Identity Security, and I will be your moderator today. Before we move to the presentation, just a few quick items to cover. If you want to ask a question, click on the Ask a Question button on the bottom left of your screen. At the end of the presentation, we will answer as many questions as time allows. Under the Attachments tab, you will find collateral and links to useful information, including the slides from today's session. At the end of the webinar, please take a moment to rate and provide your feedback by clicking on the Rate This button. Finally, this webinar is being recorded, and you can access the on-demand recording anytime using the same link used to connect to our live session today. Our presenter for today's webinar is Vadim Lander, CTO and Distinguished Engineer for Identity Security at Symantec, a division of Broadcom. Vadim is a recognized IAM expert, having architected, developed, and led multiple highly scalable IAM solutions to become industry leaders. Many of you know Vadim as the architect of SiteMinder for Integrity, where he designed the scalable architecture and ran SiteMinder engineering. He then joined CA when CA acquired Integrity. At Symantec, a division of Broadcom, Vadim is focused on evolving IAM to meet the needs of the world going digital. I would also like to introduce Thirmal Bandy, an architect at Symantec Identity Security, who will walk us through a demo later on in this presentation. With that, let's get started. Vadim, the floor is yours.
Thank you, Becca. All right, good morning, good evening, folks, wherever you may be. I'm going to switch into slide mode right now. Okay, so we're going to cover a bit of zero trust. This is going to be a technical presentation. I hope you'll enjoy it. We're going to talk a little bit about zero trust, what it is, but we're going to be focusing on APIs. We're going to be focusing on how do you manage zero trust in a world of connected systems. It's actually pretty interesting how this is coming together, and we'll tell you, what our perspective on this is. So why zero trust, right? So zero trust, I'm sure you've talked about, you've heard about it, you've seen us present it, you've read numerous presentations and documents about it, but really it's about managing trust, right? As network boundaries have disappeared and we've gone remote and mobile, it is necessary to reduce security risk, protect our data, protect our devices, protect our identities, also protect the identities of those consumers, employees, and partners that you may be working with, right? And so what zero trust does, it helps businesses reduce risk. It's all about reducing the risk, reducing organizational risk, because with zero trust, applications, services, systems, devices that communicate, with one another within the network, across networks, need to be identified, need to be properly validated. Their communications paths need to be mapped. The other thing, of course, I think we're now realizing that the perimeter, right, is gone and very unlikely to come back. And if you look at the latest, for example, reports from Gartner, 3/4 of companies expect to shift a lot of their workforce to continue remote work on a permanent basis. And of course, with the rise of mobility, with the rise of federated environments, with the rise of systems and applications that are now born in the cloud, we know that there's really no perimeter really left other than the identity itself. So we'll come back to that. So there's a fundamental shift in the way security is being approached, right? Zero trust is really about a security model, right, that centers on the belief that the organization should never trust anything inside or outside, right? Obviously, you need to trust it, but the question there is at what level, right? And that's where the risk comes in. We want to be able to trust systems, but always at a certain level of risk that we dial up and down based on policies, right? And these policies then need to take into consideration the user context, the application context, the device context, in order to properly validate the amount of risk being taken and apply that risk in whatever access management decisions being done. And so it really fundamentally comes down to three basic things, right? We never trust a system before we validate the user, before we validate the device. We try to enforce least privilege whatever possible, and we assume breach. So the fundamental model, right, basically comes down to these sort of 5 steps, right? Identity is the only perimeter. Sometimes we can say it's the last perimeter. And so we need to absolutely identify anyone and anything, right? It doesn't have to be users, can be things, can be applications. And we need to continuously authorize their access based on the level of risk, right? For example, administrators coming in with tons of entitlements, they represent risk. A user coming into an application that is sensitive also represents risk. So there's different ways of managing and defining risk. And then number 3 is we need to automatically adjust, block, allow with certain obligations access in real time in order to adequately protect against these risks, right? And while we're doing that, we need to be protecting and monitoring access to privileged accounts, right? Because privileged accounts are those that enable these systems to work with one another. So it's not just about our identities as end users, but it's also about the identities of those systems, applications, and devices that are communicating on our behalf. And while we're all doing that, we want to be able to understand who has access to what, so we can govern people's access, we can govern system access to enforce the least privilege, so that we ensure that the devices and identities have only as many privileges they need to access those systems, no more and no less. And so fundamentally, this is the change, right? This is the change that the modern applications are imposing on security architectures. This is the change that remote access is imposing on security architectures. And in generally, if you actually take a step back and say, okay, well, how are we doing this? Well, this is how we live our lives, right? We're being careful about where we go, what time of day we go there. We're being careful about observing our surroundings. And so what we're doing now is we're basically taking the zero trust approach into the world of IT management. So that's a little bit on zero trust. So what's interesting now is the business is moving forward, right? The business has moved on now into consuming cloud services, right? We no longer just build applications inside our network perimeter data center, right? We've started a long time ago, we started to consume cloud services. We're building new applications in the cloud. We're taking advantage of those services. We're making a lot of API calls. Specifically, we wanted to focus this session on the business of APIs and how does the world of zero trust come into the world of APIs, because APIs aren't necessarily just about identities. It's not necessarily just about applications that are making APIs calls. It's a combination of applications trying to do work on our behalf, or it's applications running in the background, doing work on behalf of themselves. So it's a lot of connectivity between and across these environments. And one of the challenges in these environments is that they're all built by different organizations, by different people, ultimately having different disjointed security domains. And that's an issue, right? So how do you architect a secure application delivery, right, that's made up of distributed APIs in the world of distributed environments, right? Really different security domains that were built on different identity systems, different trust systems. And so in order to accommodate this, it requires having a digital identity framework for managing trust in a coordinated and systemic way. And once this trust framework is in place, right, as I mentioned before with zero trust, we need to be able to introduce risk, right, that may be managed in different kinds of IAM systems along the key paths of this application delivery chain. And if you take a step back, we actually do this today in real world, right? We use passports, right? Passport is a great way to manage trust. So the trust has been tokenized with passports so that we're able to get onto airplanes and we're able to get into different countries, right? And then countries trust the token called passport. Same thing with driver's license, right? Our ability to drive across within a country or even across countries has been tokenized, right? Using driver's license, and then the infrastructure is now being learned how to manage these kinds of trust environments to enables us to travel, to enables us to drive. And so the answer, the solution to working across distributed infrastructures going forward is really about tokenization of trust. And now we're no longer doing it with licenses. No, we're not doing it with passwords, but in the world of IT, we're doing it with tokens. And we want to talk a little bit about sort of this tokenization. And over the last many years, we invented a number of standards such as OAuth2, such as OpenID, such as JSON Web Tokens, such as SAML tokens, and other kinds of standards that help us manage this business of tokenizing trust. And really what it does at the high level, the tokenization of trust is all about codifying privileges required to access resources. What do you need? How much of that do you need? When do you need it? For how long do you need it? So it enables us to continuously evaluate, right, what the identity is, what the risk is, what the session is, and continuously ask questions, right, about are they still up to date? Is the risk, low enough for access to be granted, right? And it just as importantly is enables us to use open standards, right, to request and redeem these kinds of tokens, which helps basically the world of IT to seamlessly integrate these architectures into the environment. So let's talk a little bit about how does it actually work, right? So as I mentioned, the main issue with distributed environments is that we have disjointed security domains, right? How do we solve this? So the first thing first is we need to be able to identify risk pools. I call it risk pools because in order to model access, in order to model the policy infrastructure, we have to understand where the risk hides. Is the risk with identities having too many entitlements? That's one element of risk. Is the risk with applications or resources having too many policies? They can be quite convoluted, and whenever you have too many policies, it becomes really hard to manage. Is the risk with the cost of breach? Sometimes we've seen a lot of our customers looking at risk from the monetary perspective. There is a breach, how much does it cost? If it costs a lot, it's a problem. If it costs very little, it may not be that much of a problem. Is the risk with the customer satisfaction? Is it brand reputation? So you want to look at where are your pools of risk, and then focus on those areas, and then put processes and technology in place to manage that. And once you understand where those risk pools are, it's about adjusting controls. Right. So first, it's always going to be about the authentication policy, with so mapping the authentication policy to the amount of risk. So the higher the risk is, the stronger, more compensating your authentication policy needs to be, right? Because it always starts with the authentication, right? Then if you have a lot of different resources, if you have a lot of convoluted policy infrastructure, if you have a lot of different resource pools or data pools, right? You may want to look at the reducing complexity by organizing risk into more manageable constructs, such as creating a taxonomy, based on whether it's a secret, whether it's confidential, whether it's top secret. So creating a bit of a structure of a taxonomy that lets you sort of move away from sort of ad hoc, access management, and rather going with more structured, taxonomy for how things are protected, right? And so at that point, you have the option to add a bit of classification, such as, are you managing by channel? Are you managing it by project? Are you assigning tags? So again, move away from sort of arbitrary ad hoc policy definitions and focus on more codified, more structured way to represent and manage the access, right? And at the same time, it's just as important to continuously observe what is going on, look for anomalies. So this is where artificial intelligence and machine learning starts to come in, right? It helps us understand who's doing what, why they're doing what they're doing, right? Who gave them the rights to do that? And so use that information to bring that back into our policy infrastructure. So we talked about tokenization of trust, right? Just like with licenses and passports, there are processes to do that. There's a process to acquire those tokens. We get identified, we're then granted those artifacts, and then we go about using them. So how do you do that, right? What are the key components in the security architecture that requires that kind of allows us to manage trust across distributed systems. So as I mentioned, the answer to that is tokenization. And so using, for example, standards such as OAuth, such as OpenID, such as JSON Web Token, and other kinds of standards, we're able to do that. And so the three critical components that are required in this architecture, everything starts with the authentication. Right? Authentication is the very first service that you need to have in your possession in order to properly identify the identity, the application, the device, and make sure that they are who they say they are. And so we'll talk about that. There's a sort of some modern capabilities that need to be made available in the authentication service. For example, passwordless, for example, very strong authentication policy, being able to apply, accept any identity and validate it, with any kind of authentication factor. But the authentication service is the first thing. And so the authentication service is what defines what a trusted identity is. And as part of the authentication service, we also started to introduce the notion of a risk service. So we now see identity management needing to have a risk service that is able to determine risk on the basis of different contexts. It's who you are, where you are, what you've been up to, your behavior, what devices are you using, can we trust those devices, the risk of the device itself, the risk of the client, asking for access. So all of that comes into the risk service, and the risk service is then able to sort of provide a score, a multidimensional score, right? And once our identities, sort of digital identities, are minted, they're minted for a period of time, which would then begin to tokenize with the risk placed into the token, right? And then enabling applications that are trying to interact with other applications using APIs, enable those applications to request access tokens. Specifically, access token, in this case, I'm using JSON Web Token, but it doesn't have to be JSON Web Token. It could be, any other kinds of tokens as well. And so what's the important thing here is that these tokens are then built and acquired, redeemed, refreshed, what have you, right, for a specific period of time. The less amount of time the token is legitimate, the more opportunity you have to keep revalidating the risk, to keep revalidating the token. And as these tokens basically get requested by various API clients and handed off to applications to perform work, it enables the security and identity infrastructure to properly validate, right, who the requesting clients are they allowed to do that? What are their privileges? What are the identities on whose behalf they're trying to perform that work? Are those identities legitimate? How much risk is being taken? And so the process, the end-to-end exchange of identity and the end-to-end exchange of tokens now has become fully enabled for both the issuing, determining the risk, and then using that risk in various policy decisions. So this is a high-level architecture. In one of the upcoming webinars, we'll be diving more into the business of authorization, the business of session management, and what actually happens here. But at this, for now, I'm just going to say that really the tokenization is the key, right? And as just like we're able to live in the real world securely, most of the time in the IT infrastructure world, the tokenization of trust now, because there's no longer a perimeter, is kind of the architecture to look for. So let's move forward. So let's talk a little bit about what is making security tokens trustworthy. What are the trust features of a security token? I don't know if folks have ever looked at it this way. There's actually multiple components of a token that make up the trust ecosystem, right? So obviously we have the validity. When does it start? When does it end? When is the token valid? Just like your driver's license, right? Your driver's license is typically good for some number of years. Who issued it, right? Do we trust the issuer? There's non-repudiation built into the token infrastructure. That's the signing, is the token signed by the right authority. There's confidentiality, right? Which is perhaps in some cases tokens need to be encrypted because the infrastructure or the organization requires confidentiality to be in place. There's ownership. There's ownership is what we call token binding. So it can be, tokens can be bound to different kinds of identities. They can be bound to user identities. They can be bound to machine identities, but the binding is also part of the trust ecosystem. But the three critical elements, right, of a token in terms of trust management is what I call the trust scope, the permission scope, and the risk scope. The trust scope basically determines where the token is valid. Okay, so we sometimes use the word audience to mention where the token is valid. It's very important because tokens, some of the time or most of the time, depending which tokens you work with, are bearer tokens. So just by having a token, right, to whom can it be presented? For whom is it issued? It's very, very important that tokens can be presented only to those parties that were intended, that the tokens were intended for. There's a permission scope. Permission scope is typically about coarse-grained permissions, not fine-grained, but coarse-grained permissions that enable clients to access APIs, access resources with or without identity propagation. So typically, these permission scopes built into tokens aren't meant to completely replace fine-grained authorization models that can be implemented with ABAC or RBAC, but they're mostly meant for clients to be able to be permitted to access specific APIs with certain level of authority. And then finally, which is really now new because of zero trust, is the risk scope, right? The risk scope is basically associated with the state, is a sign, right? Reflecting the state of identity, right? Was the identity risky? Well, just because the identity is risky doesn't mean the bank may not allow the deposit, right? But if the identity is risky, right, the bank may lower the amount of withdrawal amount, for example, right? So risk can then be associated with the end user identity. Risk can be associated with a client identity that is making the API call on behalf of itself or on behalf of the identity. So very, very important now that we consider risk to be sort of an integral component of our security infrastructure. As part of the security infrastructure, based on tokenization of trust, the token themselves should now have risk, and therefore enabling that risk to be consumed in a number of various infrastructures and policies and so on and so forth that actually act on those tokens. So let's kind of put this together, right? So going back, right, if you look at the trust ecosystem, okay, somewhere you're going to have a policy. And so what does it mean for you to say that I've got a zero trust policy? Zero trust policy means that you need to be able to say who is trying to access what, but you also need it to be done based on continuous verification of risk. And that's where tokenization comes in, right? So the subject of representing the token, right, now has the permission scope, right? How powerful is the token? Has a trust scope, where can the token be redeemed? But it also has the risk scope. And so this kind of architecture, right, enables us to start defining and practicing a zero trust access policy. And if you have that, if you have zero trust access policy, you know that you can always dial up and down the amount of risk, the level of risk that you're willing to take to protect certain kinds of access. So what are the best practices, right? We've talked about the API client. So here we're obviously not going to go into the full API management or API gateways. This is quite a complicated story, but all we're going to say is that in order to integrate zero trust, right, into the world of API management, we're typically looking at the world of now OAuth2 and OpenID Connect, right? That were designed to secure API resources by a token-based model. We specifically invented and evolved these standards to be able to adequately authorize, delegate access to resources, and appropriately authenticate identities and applications, right, as required to establish the identities, right? So we want to make sure, right, and we're advising the tokens now begin to include risk context, right, which will enable adoption of risk-based policy decisions. It's always been a challenge going back. It's like, if I were to measure risk, how do I bring risk into my policy infrastructure? It was always an ad hoc integration, it was always a custom integration. But as we move forward, this infrastructure actually enables us, right, to seamlessly incorporate risk context into our access management ecosystems. And so the tokens then enable API providers, otherwise known as resource service, to authenticate clients and users based on continuous verification of risk, right? So if the risk is high, then we may reject that. If the risk is, good enough, we'll accept that, right? It may change, 5 minutes later, the risk may become higher and we may refuse the service. And obviously, just by working with tokens, what it does, it enables applications to access resources for a period of time without having to constantly re-authenticate credentials. That's very, very important. So tokens also enable us to move away from IDs and passwords. It enables us to handle authentication once, handle federated authentication once, and then having step up and whatever authentication is required, and then using that trust, right? Using the trust and building the trust into the token, which can then be used to acquire access to a service. A lot of times we hear questions related to authorizations regarding tokenized access, which is with the tokens, there's a notion of scopes, which are privileges. So how do you make a decision whether you need to be using scopes, whether you need to be using roles, whether it's ABAC, RBAC, doesn't really matter. Fundamentally, it's really up to the application. However, the point is that we want to make sure that the authorization policies use the risk context as input into policy evaluation, right? And then from the sort of access management perspective, right, the delegation of authorization, the delegation of authority that these standards were designed to implement, enables users to grant permissions for apps to access resources, right? And so those permissions are then represented through tokenization of privileges, otherwise known as scopes, and those are the privileges used to access the APIs themselves. Now, within the API itself, obviously there is a comprehensive policy management infrastructure based on some business logic, based on roles, based on ABAC, based on policies that authorize the subject accordingly. So to underline this, we're interested in risk context to be made available to policy evaluation. Tokenization is a great way to do that. The scopes within the tokens are great for authorizing the client to actually make the API call, right, in a specific context, okay? And then within the application itself, the RBAC, the ABAC, or whatever kind of business logic, whatever kind of policy-based, is all about authorizing user-based functional permissions as required by applications business logic. So the scopes are mainly to authorize the clients, and the roles or ABACs mainly to authorize users. So, but coming back to the main point, we want to see risk context being injected into the tokens and then having those tokens delivered to applications no matter where they are, so that the world of APIs, no matter where they're located, start to understand the notion of risk and start to act and enable us as policy administrators, right, using those systems and applications to enable us to define different policies based on risk. And that actually gives us zero trust. Okay. So just an example, right? If you were to have this kind of infrastructure, what would it look like? Well, it so happens that our API gateway, right, integrates risk by delegating user authentication to our authentication management solution, right, which we call the API Authentication Hub, and we'll actually talk a little bit about that. So no matter where the gateway sits, where it's protecting, mobile flows, or it's protecting, custom code, or protecting microservices, right? The policies that are built to secure those interactions, right, can be made to incorporate the risk scope, right? So that you can now begin to define policies based on your notion of the risk. And in order to establish that, right, we want to make sure that as I mentioned, that the authentication, right, which is the last perimeter now, right, or maybe sometimes the only perimeter left, right, can be adequately asserted, right? So, and that requires that an authentication system with a flexible, capable authentication policy, dialing up or down the level of authentication with various requirements, such as FIDO2, passwordless, OTP push, whatever your choice is, can adequately protect, right? Can adequately protect the identity by establishing, right, the level of risk, right? And that's where the risk engine starts to come into the picture, right? This is where we need to be looking at the behavioral analytics, right? We need to be looking at, network infrastructure. We need to be looking at, trusted devices. We need to be looking at, fraud. And so the combination of various risk rules, right, begins to construct what we call this risk fabric, right, which can then be turned into a score or a set of scores that can then be made available to the policy engine. So in this particular case, our solution called VIP Authentication Hub, right, it seamlessly integrates with a gateway service, right, which can then protect an API and then apply risk-based policies to properly secure those APIs with zero trust. And of course, it can be your authentication service, it can be your API gateway, or it could be your own policy enforcement point that ultimately sort of ends up doing the same kind of, has the same kind of behavior. So, so moving right along. Right. What I also want to bring in, and I mentioned it in the last webinar, I think it's very important. I actually think that this is going to become the next really major standard that enables these disjointed security domains to communicate with one another, right? So one of the major problems in distributed computing is, so for example, logging in and using service is simple, but how do we know what happens somewhere else, right? And so the continuous risk-based access evaluation protocol, which was invented not that long ago, right, is about allowing identity providers, right, which is typically the owner of identities, that's where we authenticate, or that's where we do business with, to make statements about the behavior, about user behavior, about application behavior, and then send those security events to other parties who have registered. So for example, if you go back to an application built in your data center, or maybe built in a cloud, and then using a third-party application, right, which, for example, you're integrating with Salesforce and you're pulling some data in, and how do you know what happens across these disjointed security domains? And so continuous risk access evaluation is really about enabling exchange of security events. So for example, user was deemed to be risky at Azure, and then Azure sends you an event saying that, we think that this user has exceeded the particular risk threshold. What do you do about that? Well, that's your choice. But you would probably either lock the user out, disable the user, or maybe just reduce users' privileges immediately, right? Go back to the tokenization of trust. You can actually find out about within seconds, and then lower the overall user's ability to access certain data artifacts or certain resources. Or you can also lower applications' abilities to make API calls so that they become less powerful, right? So very, very appealing protocol. It's definitely something that we are now seeing a lot. The Azure picked it up, Google Cloud picked it up. We're looking at bringing this into our infrastructure, security, identity management infrastructure as well. And so I think it's perfectly aligning with tokenization of trust, and I think it's going to be one of the key elements of zero trust, moving forward, to be able to bring sort of real-time view of risk and real-time view of what's going on across our application delivery ecosystems. Okay. So we want to switch. So now that we've talked about zero trust and we've sort of aligned, explained how tokenization of trust can help build a secure environment, right, that enables applications to communicate across disjointed secure domains. We've also underlined the need for authentication, right, to basically serve as the last perimeter, right? So who we are, right? We have to be able to bring this kind of service. I actually call it fabric. Authentication has to be part of your organization's fabric. And really, it's about being able to connect any identity to any application. And so we have developed technology called VIP Authentication Hub, right, that enables an organization to consume authentication as a dial tone, practically as a dial tone, right, and enabling pretty much any kind of identity, whether it's locked up in your LDAP or databases, whether it's sitting in your Active Directory, whether it's in Azure, where it's in a number of identity providers, where it's a social identity. Really connect those identities with the right level of risk that you need, right, to pretty much any application out there that has a way of integrating through a modern protocol, such as OpenID Connect, such as SAML, or an application that is an off-the-shelf app, already exposing those capabilities, or more classic applications that are protected by web single sign-on systems, right? So, pretty much these days, almost every kind of system or application has a way of delegating its identity, question about authenticating identity. And so this kind of dial tone is really required, right, in order for your infrastructure, whether you own it in your data centers or whether you run it in a cloud, or whether you've integrated with a partner, but you really need to have the ability to authenticate identities, right, with a certain level of assurance, which requires that you leverage modern authentication methods, that you also have a way to establish and manage the risk. And once you have that authenticated identity, the tokenization of that identity can then basically participate in the overall trust infrastructure that you will have established through your trust management systems. So we're going to talk a little bit about this capability. And in fact, Thermal will be giving us a demo about this and what we can do to sort of help you with your authentication challenges and opportunities. So just to summarize this before we get into the demo, we want to make sure that as we move beyond corporate perimeter, as we uptake applications that are running anywhere, as we build application delivery ecosystems that spanning multiple security domains, right? It's about any identity, any device, any app. In order to do that securely, you have to have zero trust, right? Your solution architecture does need zero trust principles, right? And what this architecture does, it helps you create a secure distributed ecosystem, right? So the distributed security domains, in order for the application delivery to work securely, consistently across distributed security domains, you need to be able to pull the identity out, you need to be able to pull the risk out, and you need to be able to apply policies, right? Apply risk and identity across within these different security domains to be able to consistently manage the amount of risk. And then tokenization of trust does support that. It is a great evolution of how we think about security. And it enables, in this particular case, our API service to continuously verify risk, therefore continuously to provide a secure dial tone, right? Now, we've also observed that the identity is the only perimeter left, right, that is shared across disjointed security domains. So therefore, managing the trust and managing managing security across these delivery systems requires that we adequately establish the level of this identity, the risk of this identity, right? And in order to do that, right, you have to have an authentication dial tone. You have to have a risk-based, right, very flexible risk-based authentication policy, right, that can then be brought into the fabric of any one of your application ecosystems, so that you can adequately balance risks, right? On one hand, security risk, and on the other hand, the user satisfaction, right? Always the big challenge. So we'd like to, at this point, so we can do the demo and leave a little bit of time for questions. We'd like to give you a thermal. It's a little early. Let me come back. So let me sort of talk about the demo itself. So we're going to show you kind of a modern way of working with authentication. So we have built a marketing application in the cloud, right? I don't want to use my resources anymore. I want to use the cloud. So I built a marketing app in force.com. I happen to be using Salesforce as a cloud. We will manage access to our applications using zero trust approach. So we built an app, we're using some APIs, we're using some web apps. And so our zero trust approach basically enables us to map, proper risk to capabilities. So we're mapping functional capabilities to risk, right? And then because we've defined various risk pools, right? We will then assign or align different kinds of authentication to those risk pools. And so there are 4 risk pools that are present in this application that Thermal is going to show us, and Thermal is going to show us how we are managing that risk. So we have 4 kinds of identities. Okay, our existing identities are in our marketing database. Happens to be that could be anything, right? So these identities, they want access to Chatter. They want to participate in service. We want them to participate in service. We want them to be, participating in promotions. And what we also want to do is we want to not only improve security, but we also want to improve user satisfaction. So we're going to give them passwordless. We're going to switch them from using a password that we all hate, and we're going to just give them passwordless, right? So these are the millions of your identities. These are your customers, your consumers, your advisors, and you have them in your marketing database. You now just don't want them to be using passwords anymore. But we also need to be running TV commercials, right, to attract new consumers, right? We want new customers to come in, and we also want them access to this marketing platform. We want them in surveys. We want them to talk about our products. We want them to be participating in promotions. But we don't want them to be sort of going through a sort of complicated registration process. We just want them, we just run a commercial. I just want them to use their social identity, but I want them to confirm their identity, right? And we typically, the easiest way to confirm an identity without bringing in a sort of more sophisticated ID proofing and having people, look into cameras and whatnot, is just to use their mobile phone. So at least we know that this is a legit identity. It actually has something that we can validate. Now, we also outsource functional administration, right? This is a modern app, so I don't want to be hiring people. I don't want to be, putting together a team to do this. There are marketing organizations out there that do this best, and that we've outsourced the functional administration of this marketing app and marketing campaigns to a marketing contractor, right? So we just call it BRCM Dev contractor. They will run our marketing campaigns, and we want, there are people all over the world. We want them to be using their own identity. We want them to be using their own corporate accounts. We want them multi-factor. We want to make sure that it's really them by using our mobile authenticator with the mobile OTP code for multi-factor. So very simple, very straightforward. We don't have to invent yet another identity. They already have one in their corporation, with the contractor. We just want them to be stepped up. And then finally, the actual administration of these IT assets, right? We are using force.com. We have Salesforce accounts. There's definitely some administration going on. So it needs to be done by our own administrators, right? So our own IT administrators, right, they will be able to manage infrastructure on force.com, but they will be using our Active Directory. They'll be using our directory. We have to externalize it through Azure AD, but it is our directory, and the only way they're going to be able to access and sign into the Salesforce administration is with the risk policy that it restricts that there are on our corporate network and not on anybody and not anywhere else. So we don't want them to be able to log in from Starbucks and get access to sensitive cloud resource infrastructure. So we're making sure that they're on our corporate network. So with that, Thermal, it's all yours. If you don't mind, just bring up the demo and take the audience through through what's going on.
Sure. Thanks, Vadim. So let's start with the like as Vadim talked about it, right? Like, so it's a marketing app that's been built in the force.com that is mainly helps in demonstrating the various capabilities, like, okay, that Vadim has talked about so far. So we'll talk about the first scenario, like, okay, where you have the customers, like, okay, in the marketing database already. So these are all the existing users, like, who have been using the system already. So the main reason, like, why they access the application is they participate in various surveys, promotions, and so one of the things that, like, okay, that we wanted to provide is that, like, we wanted to provide an improvised, like, sign-in experience with the passwordless authentication. So if you have seen it, like, means the user we burn, like, okay, he has been prompted, like, okay, with a passwordless authentication, which is mainly, like, okay, driven through either a security key, or, like, okay, it is done through biometrics authentication stuff. So this is a kind of a modern way, like, okay, in which you actually provide a new increase, like, okay, earlier, like, they used to use a password based one, like, okay, now they have moved on, like, okay, to a seamless line and say experience with the passwordless stuff. So once they log in, like, they can get through the polls, like, okay, they can get through the surveys, and then, like, okay, they log in. Now comes the other scenario, like, okay, where we have been marketing, like, okay, via TV commercials and all, like, where we are trying to attract new customers. Now these new customers, like, okay, they want to be part of our surveys or promotions, but they wanted to come in with their own identity. So in this case, so what we wanted to give them is, like, we wanted to give them an ability, like, where they can actually choose from few of the social identity providers, and then, like, use. In this example, like, okay, we're using the Google, like, okay, and Vadim Lander, like, okay, is using, like, okay, his Gmail account, like, and is trying to access into the application here. But once again, we just don't want to just take the identity, but we wanted to assert that, like, this identity is a genuine identity. So for that purpose, like, what we are making sure is that, like, okay, we are asking for their phone number, and then we are sending a security code, like, okay, asking them to confirm, provide the security code, so that we know that it is a genuine user, like, okay, and genuine identity that is trying to access our application. So once the new consumer, like, accesses it, like, okay, once they enter the security code and it's been validated, we know it's a genuine identity, and we provide access to the application. So now this user has almost the same privileges as the existing user who is there in our system, who has been doing, like, okay, who has been participating in our polls, who has been participating in our service. So they can do all those things in here. Now moving on, we want to talk about a third scenario where we have means, like, this application's functional administration is being delegated to a contractor, and we want the contractors to use their own corporate identity to get into the system. But at the same time, like, okay, while we allow them to access, like, okay, with their corporate identity, we wanted them to go through an MFA process, which kind of allows us to make sure that, like, it's not been. So in this case, like, okay, the corporate account, like, of the Broadcom dev is Okta, and, like, once the user are authenticated with it, kind of take them through MFA process, like, okay, in this case, we use the mobile authenticators as the second factor authentication here. And once the user, like, okay, enters the security code from the mobile authenticator, the system validates that this is a genuine user, and, like, the functional administrator can now come into the system, and then, like, okay, they can do various things, like, okay, managing the chatter or the service content or marketing stuff in there. So if you're seeing, like, we have covered three scenarios so far, like, okay, one is, like, we talked about existing users who are part of our database. We talked about users, like, okay, who are coming with new consumers, like, who are coming with their own social identity into it. And the third one is, like, we talked about the marketing administrators, the functional administrators, like, okay, who are able to log into the system using their own corporate account. Now comes the fourth scenario, like, okay, where we are talking about the IT administrators. So the IT administration, like, okay, it is been left to our own administrators, means like, okay, our own internet administrators. So we want them to log in using the corporate Active Directory. So in this case, like, okay, we are using, means like in our corporate directory is nothing but the Azure AD. So where the IT admins are being taken to the Azure AD authentication stuff, like, okay, once it is in, like, they can get into the system. But one thing to highlight in here, but before even the user is being taken into the authentication stuff, there is an authentication process, there is a policy, and there is a risk evaluation that has run in the background that kind of ensures that this particular access as a corporate admin, like as the IT admin, is really coming in from within our corporate network only. So we kind of are ensuring it through the policies and also through the risk that, like, that this user, this administrator is not accessing it outside of our. So once the user is in, once the IT admin is in, like, they can manage the apps, they can manage the various things like associated with our account, with the application stuff, and then, like, okay, they can log out from there. Okay, so this is how, like, okay, authentication hub, like any identity anywhere, like, okay, and any app access. I think this is how, like, Auth Hub helps, like, okay, in managing that particular functionality.
Thank you, Thermal. Great demo. So just folks, again, just to underline, this is a modern sort of application effort. I'm going to put up a slide. We built an application on a cloud. We didn't have to bring any infrastructure with us. We pointed to an authentication service. I call it authentication dial tone. It was able to manage all of these authentication policies. It was able to bring in modern authentication factors. It was able to integrate with just about any kind of identity out there. You were able to do all of this, right, without having to write any code. So if you're a consumer of this, you can just develop whatever your core business proposition on a, let's say in some environment, let's say a cloud, and then seamlessly integrate, right, with an authentication service that does a lot of this for you. So with that, we'll switch into question mode. If you guys have any questions, please do take a look at some of our earlier webinars. The decentralized identity platform, kind of the navigating the path to digital identity. How do you manage it with a way to incorporate SecDevOps into your environments, right? And then as we gave you a bit of a preview right now with authentication, but we have also a previous session where I talk about our security services platform, which authentication is one of the capabilities, one of the services there. Risk management is another service there. And as I mentioned, going forward, we will be expanding the series, and I'll be focusing zero trust with authorization, zero trust with session management. So I'll be putting it all together and basically putting together kind of a view of what a sort of a holistic digital identity and access management infrastructure has started to look like, and how it's going to be continuing to shift towards sort of dealing with zero trust in a modern way. With that, Andy, Becky will open up for questions if there are any.
Yes, Vadim, we do have one question. I'm going to go back to slide 16, pull that up. So the question was asking, what does CAEP stand for?
It stands for Continuous Access Evaluation Protocol. It is really a protocol that a lot of organizations, and I would say probably for the first time, have collaborated. Microsoft, Google, Oracle, and CA, and other vendors in the identity and access management space have contributed a lot of work into this working group. I also expect that we will see, we are doing work in the OpenID space, right, to bring this into the sessioning ecosystem, right, with the back channel session management and automatic event discovery and registry.
Great, thanks, Vadim. As a reminder, if you want to ask a question, you can click on the Ask a Question button on the bottom left of your screen. And we did get another question asking if this presentation would be available later, and the answer to that is yes. You can find the on-demand recording at the same link that you joined this live presentation. All right, well, that looks like it's the end of our questions. So I want to thank you everyone for joining today. Before you sign off, please take a moment to rate today's webinar and download the materials in the attachments tab. Thank you, everyone, and have a great day.
Thank you, folks.